So now another important concept is the gradient of the line. So the gradient of the line, you actually, it's called M, and so it's really just y over x, sort of. Okay, so you need to think of it in terms of this. So your displacement in the y-axis over the displacement in the x-axis, that will be your y-axis, your gradient. So the displacement in the y-axis here is y1 minus y2. The displacement in the x-axis, or the distance in the x-axis, would be x1 minus x2. So that will be the gradient of this line. Okay, so for example, if I've got 2 points P 1, 2, and then I've got Q, which is 2, 3, and then I take this as my first point and that as my second point, our gradient is going to be y1, which is 2, minus y2, which is 3, over the x, which is going to be 1 minus 2. So in this case, we'll have minus 1 over minus 1. So our gradient is going to be 1. So now we got the gradient, and so remember we said that this line has got the gradient called m. Okay, usually they represent it as m. So now the whole line has got a gradient that we are calling what? We're calling m, which is here. Okay. Now, this section here will have a gradient called m2. That section here, it will have a gradient called m1. So we have m1, we have m2, and then we have m this side. Now, remember, this is still on our number line. So it could be something like that on our Cartesian plane. Okay, it could be something like this, where we have our x-axis, and then we have our positive y-axis this side. Okay, now, the next thing that we need to remember is that all these gradients are sitting on the same line. So if you get a section of this line here, it will have the same gradient as another section on this same straight line. On one condition, the condition has to be that the line is straight. Okay? It doesn't matter if it's horizontal or vertical or at an angle, as long as it's a straight line. If I got this line here, okay, that will be my gradient. If I got my line, which is at, then it will get that particular section, the gradient will get the gradient of the whole line, as long as it's a straight line. Now, let's see what this means. It means that we're saying that m is equal to m1, right? Which is equal to m2. What is the implication of this? The implication of this is that we can get these two parts and isolate them. Okay, so we get m1 is equal to m2, like that. Now, in our previous section, we saw that we could actually calculate the gradient by comparing these 2 points. And so we're going to compare these points, and then we compare those points. But with one catch now, that these two are actually, they're actually equal. So what do? We start with x. We start with this one. Okay, so we say the gradient was, remember the formula for the gradient was m is equal to y2 minus y1 over x2 minus x1. So the ones together, that's a secret, the twos together. If you mix up to say y2 minus y1 and then x1 minus x2, your gradient will have a wrong sign. Okay, so now here what do we do? We say x, we say y, which is here. We start from here going down. Y minus, the next point is y1, okay, over x minus x1. We make sure we're doing the right thing. Then we go and do the second part, which is here, the second part there, right? So this second part will give us y1 minus y2 over x1 again minus x2. The subscripts are the same on each side. Make sure, because this will be like a x0, y0 there. All right, so we take this guy and we take him across there. So we said whatever this is doing here, it does the opposite the other side. So if I was adding this, I go and subtract it there. But we know that obviously we multiply with the reciprocal here, but we know the shortcut. So we say y1 like that is equal to, so this is dividing here, it will multiply the other side. Okay, this is y1, y2 over x1 minus x2. We maintain this, and then we put this in brackets. Then this has come and visited us this side, so it will become like that. Okay, so that is our equation of a straight line that is going through 2 points. Normally they emphasize to say this is through 2 points. Our points are what? Our points are P, and another point here is Q. Sorry, this is P here, and another point is Q. This is not P. So P is here, Q is there. This is any other point. This is flexible. It can be anywhere. All right, so this is the equation of a straight line that is going through 2 points. Now let's do an example. So if this one here, okay, was now we're looking at it from the positive quadrant, okay. So if this was 2,8, right, and this one here was negative, because it's in the negative section here. If that was, let's say, negative 2, negative 4, like that, what would be the equation of that line? And this is a special case here. Remember, we looked at gradient, because this is gradient here. Okay, so what happens here now? We look at these points. We're saying this is point 1 and this is point 2. So what happens? We are going to get y minus x1, y1, which is 8, okay, equal to, then we get our y1, which is 8. Our y2 is minus 4, so we're going to say minus 4 here. And then what is our x1? Our x1, we say is 2. And then we're going to subtract our x1, which is what? Which is minus 2, like that. These we put in brackets. Always be in a habit of putting brackets, because that helps you to segment your work. Okay, so now here we go to x minus x1. X1 is what? Minus 2. X1, sorry, it's 2. It's 2. Like that. Okay, so let's continue. So this is going to give us y minus 8 equal to, okay, equal to, we continue here, there will be positive there. So we know that it's 8 plus 4, which is 12. This gives us a 12. This we know is going to be 2 plus 4, 2 plus 2, which is 4. So we divide by 4. And this is going to maintain what it has, like that. We continue. This becomes y minus 8 equal to 3x minus 2. Continue it there. This becomes y minus 8, and then this becomes 3x minus 6. Very careful. We need to be very careful with our signs. So that becomes now y equal. Now this moves the other side and becomes a positive. So that's positive 8 minus 6. So that gives us 3x plus, okay, 2. and that will be our equation of this line. Okay, now there are special things here. This is going to be where it crosses the y-axis, and then this is going to be where this is going to be the gradient. Okay, why are we saying that this is where it crosses the y-axis? Because when x is 0, it's going to be there. So when x is 0, its y is going to be 2. So this is going to be 2. There's a special formula that we can derive now based on this case. So that will be our next section. Thank you. So another variation of this equation then is to understand the application of gradient. So when the line is moving in that direction, we say that it has a gradient which is positive. Okay, so the gradient for this line is going to be positive. Once the line is moving like that, then we say that the gradient is negative. Okay, you can actually work it out and it will be negative. And then once the line is like this, it's following the x-axis. Okay, we say that the gradient is 0. Okay, so this is what we call the 0 gradient. And then when the line is vertical, following the y-axis, then that we say that the gradient doesn't exist. Okay, it's non-existent. So the gradient here, there's no gradient. Okay, now why am I talking about this? I'm talking about this because it's very important to understand that for any line that has a gradient, the line at some point is going to have an intercept if you continue to draw it. Even if it was a small line like this, just like that, I can actually extend this and get what it means here. Okay, then I should be able to work out the equation of this. So another variation of the equation of a straight line is the equation that uses the intercept. So now let's work it out and see what the general equation of a line going through an intercept is going to be. So now if we consider the intercept will be where we are saying that x is 0, and then the intercept, they give it letter c normally. Now you have xy like we discussed before. Now there are two concepts that we're going to put together. This concept here, and then another concept we worked out what gradient was, and we said it was m. Okay, so we said when you have a situation like this, you have your gradient, right? So here we're going to have y minus y1 is equal to, now we're going to have m here. We're going to replace this whole expression with xm. So this becomes mx minus x1, like that. Okay, so that becomes the next step of our equation. Okay, now that's the first part. Remember, this is the first part. So this is an equation that's actually usable. You can actually calculate the gradient, put it here, and then get the point that you're given. So this is also an equation that we can say, maybe let's say this is equation number 2. The first is this one. Okay, so that's an equation that you can apply, and this is an equation that you can also apply. Now we go to the third type of equation. So now we're going to get this point and replace it into this equation. So what is our y? Our y1 is going to be c is equal to mx, like that, minus x1 is 0, like that. So what is our equation if we continue? It's going to be y minus c is equal to mx, because this became a 0. Okay, now we can take this guy and throw him the other side. So this comes this side. That is how I like to do it. It's a shortcut. You can add c here and add c. It's another way. Okay. All right. So this is our equation. Okay. So this is another equation. So this is the third time. So you can actually use this to get the equation. You can use that to get an equation, or you can use this to get an equation. Okay. So if they asked maybe a question to say, find the equation of the straight line, maybe they'll give you this point here and another point. Okay. So what we have to do in that case is to calculate the gradient. Okay. And then we calculate and then we collect the C, we put it there. That will be our equation of the straight line. Let's do an example. Okay, so we're trying to get the equation of this setup here, the equation of this line here. Okay, so now what are we seeing here? We said that what I'm expecting is once I'm done, one of the checkpoints I'll have is to make sure that my gradient is negative. So what's the first thing we do is we calculate the gradient. So how are we going to calculate the gradient? We said it's m is equal to y1 minus y2 over x1 minus x2. Now, here, we need to make sure that the subscripts are sitting on the same side. 1, 1, 2, 2, like that. You don't do y2, y1, then it will give you a wrong sign. So the gradient will be wrong. And when the gradient is wrong, it means that this is in a different alignment. So now we start with y1. I'll take my first point as this one. So I'll do y here is going to be 4, right? So I'll do 4 minus 0, okay? Then I'll go down here and do my, I'll do my x is 0, and then I'll subtract my 6. So by look of things, we get a negative gradient here. Okay, so our negative gradient is reduced to that. Now we can also continue here and look at what the intercept is. What's the intercept? We said the intercept is going to be this point here. So what's the value of y at this? It's going to be 4. So we get 4. So our equation therefore is going to be y is equal to minus, this is our gradient, 2 over 3, x plus our c, which is 4, right? I can change this a little bit by multiplying throughout by 3 to remove the 3 here, to remove the fraction. So if I multiply this whole equation by 3, okay, I'll get 3y equal to negative 2x plus 12. Okay, I can also move this to the other side to remove the negative. Then my whole equation therefore becomes 2x plus 3y equal to 12. It's the same, okay? So that's our equation when we use the intercept to work it out. But what you can also do is maybe try to get this same equation using the first formula that we worked out. It also should be able to work without really having to calculate the gradient. You just put these 2 points in and then it gives you the equation. Thank you.